The National Electrical Code, or NEC, addresses the issue of running different systems, circuits, or classes of voltage within the same raceway, cable, or enclosure. Specifically, Article 770.130, titled Wiring Methods, provides guidance on this topic. Section 770.130b generally prohibits the mixing of conductors from different systems, circuits, or voltage classes within the same enclosure. However, there are exceptions to this rule, listed as items 1 through 9 within the same section. Exception 1 is particularly relevant to running fiber optic cables alongside electrical circuits. This exception states that communication circuits rated at 30 volts or less are permitted to occupy the same raceway with other circuits. Therefore, if the fiber optic cable is rated for less than 30 volts, exception 1 of NEC section 770.130b allows it to be run in the same conduit as a 110 volt circuit. It's crucial to verify the voltage rating of the fiber optic cable to ensure it meets the requirements of exception 1. If the cable's voltage rating exceeds 30 volts, it would not be permissible to run it in the same conduit as the 110 volt circuit under this exception. Always consult the specific product documentation for the fiber optic cable to confirm its voltage rating. In addition to the voltage rating, it is also important to consider other factors that may affect the safe installation of the fiber optic cable. These factors may include the cable's temperature rating, its resistance to moisture and chemicals, and its ability to withstand physical stress. Ensure that the cable is suitable for the intended environment and application. Proper installation practices are also essential for ensuring the safe and reliable operation of the fiber optic cable. These practices include avoiding sharp bends in the cable, using appropriate connectors and terminations, and protecting the cable from physical damage. Always follow the manufacturer's instructions for installation and handling of the fiber optic cable. It is also important to note that local codes and regulations may have additional requirements for the installation of fiber optic cables. Be sure to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. Failing to comply with these codes and regulations can result in fines, penalties, and other legal consequences. Furthermore, improper installation of fiber optic cables can create safety hazards such as electrical shock and fire. It is essential to take all necessary precautions to ensure that the installation is safe and compliant with all applicable codes and regulations. If you are not familiar with the proper installation techniques for fiber optic cables, it is recommended to hire a qualified electrician or installer. A qualified professional will have the knowledge and experience necessary to ensure that the installation is done safely and correctly. In summary, the NEC permits running fiber optic cables rated at 30 volts or less in the same conduit as a 110 volt circuit under exception 1 of section 770.130b. However, it is crucial to verify the voltage rating of the cable and to follow all applicable codes, regulations, and manufacturer's instructions to ensure a safe and compliant installation. Always prioritize safety and consult with qualified professionals when necessary. To further elaborate on the NEC requirements and best practices for running fiber optic cables and conduits, let's consider some additional factors. Firstly, the type of conduit used can also impact the installation. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages, and the choice of conduit will depend on the specific application and environment. For example, rigid metal conduit is often used in areas where there is a high risk of physical damage, while electrical metallic tubing is commonly used in concealed locations. When running fiber optic cables and conduit, it is important to ensure that the conduit is properly sized to accommodate the cables. The NEC provides guidelines for conduit fill, which specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors and cables. Exceeding the conduit fill limits can make it difficult to pull the cables through the conduit and can also increase the risk of damage to the cables. It is also important to consider the bending radius of the fiber optic cables when running them in conduit. The bending radius is the minimum radius to which the cable can be bent without causing damage. Exceeding the bending radius can cause the cable to kink or break, which can impair its performance. The manufacturer's specifications for the fiber optic cable will typically specify the minimum bending radius. When pulling fiber optic cables through conduit, it is important to use proper pulling techniques to avoid damaging the cables. This includes using a cable lubricant to reduce friction, using a pulling eye to distribute the pulling force evenly, and avoiding sharp bends in the cable. It is also important to avoid pulling the cable too hard, as this can also damage the cable. In addition to the physical installation of the fiber optic cables, it is also important to consider the grounding and bonding requirements. The NEC requires that all metal conduits and enclosures be properly grounded and bonded to ensure electrical safety. This helps to prevent electrical shock hazards and to minimize the risk of electrical noise interference. Proper grounding and bonding can also help to protect the fiber optic cables from damage caused by lightning strikes or other electrical surges. When running fiber optic cables in existing conduits that also contain electrical conductors, it is important to inspect the existing wiring to ensure that it is in good condition and that it meets all applicable codes and regulations. If the existing wiring is damaged or deteriorated, it should be replaced before running the fiber optic cables. It is also important to ensure that the existing wiring is properly grounded and bonded. Furthermore, it is essential to consider the potential for electromagnetic interference, or EMI, when running fiber optic cables near electrical conductors. EMI is a type of electrical noise that can interfere with the signal transmitted through the fiber optic cable. To minimize the risk of EMI, it is recommended to use shielded fiber optic cables and to separate the fiber optic cables from the electrical conductors as much as possible. In summary, running fiber optic cables and conduits requires careful planning and execution to ensure a safe and compliant installation. It is important to consider the type of conduit, the conduit fill limits, the bending radius of the cables, the pulling techniques, the grounding and bonding requirements, and the potential for EMI. Always follow all applicable codes, regulations, and manufacturer's instructions to ensure a successful installation. Moreover, to reiterate the importance of safety and compliance, remember that electrical work can be hazardous. Working with electricity requires specialized knowledge and skills. If you are not a qualified electrician or installer, it is best to leave the work to a professional. Attempting to perform electrical work without proper training can result in serious injury or even death. Furthermore, it is important to stay up to date on the latest codes and regulations. The NEC is updated every 3 years, and there may be changes that affect the installation of fiber optic cables. It is also important to be aware of any local codes or regulations that may be more restrictive than the NEC. By staying informed and following all applicable codes and regulations, you can help to ensure a safe and compliant installation. In addition to the NEC, there are other industry standards and best practices that can help to ensure a successful fiber optic cable installation. These standards and best practices cover a wide range of topics, including cable selection, connectorization, testing, and troubleshooting. By following these standards and best practices, you can improve the reliability and performance of your fiber optic cable system. It is also important to document the installation of the fiber optic cables. This documentation should include information such as the cable type, the cable length, the connector type, the test results, and the location of the cables. This documentation can be helpful for troubleshooting problems and for making future modifications to the system. In conclusion, running fiber optic cables and conduits requires careful attention to detail and a thorough understanding of the applicable codes, regulations, and best practices. By following these guidelines, you can help to ensure a safe, compliant, and reliable installation. Remember to always prioritize safety and to consult with qualified professionals when necessary. Finally, let's consider some specific scenarios and applications where running fiber optic cables and conduits is common. One common application is in commercial buildings, where fiber optic cables are used to provide high-speed internet access, data networking, and security systems. In these buildings, the fiber optic cables are typically run in conduits to protect them from damage and to provide a neat and organized installation. Another common application is in industrial facilities, where fiber optic cables are used to control and monitor equipment, to transmit data from sensors, and to provide communication between different parts of the facility. In these facilities, the fiber optic cables are often run in conduits to protect them from harsh environments and to prevent interference from electrical noise. Fiber optic cables are also commonly used in transportation systems such as railways, highways, and airports. In these systems, the fiber optic cables are used to control traffic signals, to monitor vehicle movements, and to provide communication between different parts of the system. The cables are run in conduits to protect them from damage and to ensure reliable operation. In residential applications, fiber optic cables are increasingly being used to provide high-speed internet access and to connect smart home devices. The fiber optic cables are typically run in conduits to protect them from damage and to provide a clean and aesthetically pleasing installation. As technology continues to advance, the demand for fiber optic cables is likely to increase in all of these applications. Therefore, it is important for electricians, installers, and other professionals to have a thorough understanding of the proper techniques for installing and maintaining fiber optic cables and conduits. By following the guidelines outlined in this discussion, you can help to ensure that your fiber optic cable installations are safe, compliant, and reliable.